we just got done talking about, dealt with the visibility qualities, right? The qualities of noise, contrast, and signal intensity, but had nothing to say about structure, like shape and structure of things, right? Geometric qualities of the image. That's this section, geometric qualities of our images. So we're going to see what things change the shape and shape and size of these things we're looking at, these body parts we're looking at. This is going to refer back to stuff like the focal spot on the anode, right? So understanding what we learned earlier as the line focus principle from the anode. We're going to be referring back on some of that stuff. This shouldn't be too difficult though, and I'm not going to be able to get it all out to us today, but the three things that we need to know to start off is that instead of dealing with visibility, we're dealing with recognizability. So assume you can see the thing. Now we need to be able to recognize what it is, right? That's dealing with the shape of it, shape and size, right? So recognizability or geometrical integrity requires three things. You need the most possible spatial resolution. You want your images to be as detailed as possible, right? So you're doing whatever you need to do to achieve the most possible spatial resolution, maximum spatial resolution. Notice on this next one, optimum magnification, not minimum magnification or maximum. We want optimum. As we've learned and will learn, some of us have and the rest of us will, objects get magnified when you move them away from the image receptor, right? So if there's an increased distance from object to image receptor, or a part is very thick, right? Objects get magnified. The degree by which they get magnified depends on a lot of different factors, but objects are always magnified. Sometimes we want to minimize that. Other times we want to accentuate that. We want to use magnification to help us. And we want minimum shape distortion. I almost want to replace this with optimum shape distortion, because in general, yeah, most body parts we want to minimally shape distort them, right? We want them to look as true to shape as they actually are in the real world. But in some cases, we want to purposefully elongate a body part, or I don't know if we purposefully foreshorten anything, but we purposely elongate things all the time. Has anyone here done a calcaneus x-ray, a heel? So a bunch of us. What do you do on the AP, or not the lateral of the calcaneus, but the first image, the axial image? What do you do to the x-ray tube?
You angle it.
How much?
15.
15? 10 to 15. I use something closer to 25 or 30. It really depends, right? But you angle the x-ray tube, right? You angle the x-ray tube, and the image comes out looking like stretched out, right? Elongated calcaneus, and that's done on purpose. We purposefully elongate the calcaneus, okay? So other body parts like the navicular in the wrist, the scaphoid bone in the wrist, we purposefully elongate that bone because it's a weird little shaped bone, it's positioned in a weird way, and we want to sort of stretch it out to see the potential fracture lines. Good, so we want optimum, most of the time minimum shape distortion. All right, so what's spatial resolution first? Spatial resolution, defined by the American Registry of Radiologic Technologists, the governing body who administers your test that you'll take. They say it's the sharpness of structural edges in the image. I think sharpness of detail, how detailed the edges are, okay? So we want to go, what is sharpness then? Okay, because contrast is the ability to tell the difference in image density between two structures, but it doesn't say anything about how well you can actually see the shape and size of those structures, right? Sharpness and detail give us that, and those are independent of the visibility qualities. So mass and KVP, body part thickness, not a lot of those things are going to affect the sharpness of detail, right? So we'll need to talk about here what factors do affect that. So here's what we mean. Sharpness of detail, the abruptness with which the edge of an image stops. Such as here. Image A has sharper edges than image B. You notice the line between where black turns to white is wider here. There's not a very defined edge to where white turns to black. It sort of does, right? You move one direction, it goes from black to white to black, but it's not a hard line. It goes black to kind of this blurry area, then to the white, then some more blurry area, back to black again. Where this image A is just black, white, black, very defined, sharp edge to where some structure stops and another structure begins. Okay, so this is what we mean by sharpness of detail. This is chapter 14. All right, so sharpness of detail is going to be given by a couple of things. Let's assume for now that the object to image distance is fixed, and the source to image distance is also fixed. So our X-ray tube is a fixed distance from the image receptor, and our object is a fixed distance from the image receptor. So take those out as variables, those are constants now. What's going to affect sharpness of detail are these categories called umbra and penumbra, okay? Let's talk about that. If you speak Spanish, what does umbra mean?
Umbra. See it on soccer shorts.
On soccer shorts?
Yeah, it's like a brand of
Is it really? Spanish speaking, what is umbra? It's a Latin root word, you should know it. Shadow, yeah. I don't know what the root word actually is in Spanish, but I know umbra is a Latin root, so it must be in the Spanish language. How do you say shadow in Spanish? Sombra, there it is, umbra in there, okay? That's the root of the word, okay? Umbra means shadow, okay? Penumbra is the edge of the shadow, okay? Recall back to when I was talking about the focal spot in the X-ray tube, right? The anode side of the X-ray tube, the anode face, has a spot that gets struck by the electron stream. It's got an area size to it, right? The X-rays come from that spot, yeah? The size of that focal spot, I related to talking about shadows in the room, right? I said you can either have a shadow given by all the lights in the room, very blurry, right? Or you can have a shadow given by a single flashlight, which would make a clearer image of whatever you're trying to make a shadow of, right? This is what we're talking about here. It's going to relate to the size of the area that the X-rays are coming from. When we look at the, let's draw something. When we look at the anode face, so we'll just draw like a part of the anode here, right? There's our anode, okay? We know that the electron stream strikes an area on the anode, right? And then what comes out of that, let's get a different color. What comes out of that are the X-ray photons, right? Down towards the image receptor, yeah? The size of that area is going to affect the umbra or penumbral shadow, right? You can have one anode area that is that big, right? Or you can have a larger area. Let's say your electron stream is now that wide, which makes for a larger area, a larger anode surface area. A larger surface area means a bigger spot for the X-rays to originate from, okay? Your X-rays originate from an area on the anode face. The size of that area is going to affect the size of the shadow of the body part that you project and the sharpness with which the edge of that shadow ends. The shadow is called umbra, the shadow of the body part, or the projected image of the body part. The edge of the shadow is called the penumbra. Okay, so let's see if we can talk about these things and help to understand them a little better. So just briefly, simply put, the image on the left, so let's bring this up and magnify it. The image on the left, the source of the light rays that are making, let's just talk about visible light for now, because it's easy to talk about visible light. The source of the light rays that is casting the shadow, right, is a small spot, is a single, we're just using simple stuff right now, so a single source, a single point, a point source, okay? A point source, where all of the light originates from a single spot, right? So not an actual area, but a hypothetical, just a single point, right? That doesn't occupy any space, would produce an umbra, but no penumbra. There would be no blurred edge. The shadow would abruptly end, okay? Which is kind of like you take a small flashlight, shine it down on your hand, cast a shadow. You notice that if the shadow the place where you cast the shadow is not that far from where your hand is, the shadow looks pretty clear. You can see the shape of your hand and the edges are pretty clear, okay? The smaller the source of the point of origin is, the smaller the point of origin is for the X-ray beam, the less blurred the edges of the body part are. the less penumbra you'll have. This represents the body part shadow ending, or the shadow in the real world with visible light. The shadow ends abruptly, okay? Yeah.
So does that mean if you're x-raying a hand, the image is going to be sharper than if you're x-raying a chest?
Well, so if I x-ray a hand using the small focal spot, and I x-ray a chest using the small focal spot, they will both be equally as sharp. So the blurriness, the sharpness of detail, it comes from the size of the source of light, right? Not the body part. In this case, it has almost nothing to do with the body part. And because earlier when I started this conversation a couple minutes ago, I said the source to image distance is not going to change, just for right now. Okay. In principle, the source to image distance does change, but it's too complicated to talk about all the things changing at once. Let's talk about one thing at a time, right? If source to image distance is fixed, the distance from here to here is fixed, it's not going to change for this conversation. And the distance from the object to the image receptor is also fixed, not going to change during this conversation. Then the thing that affects the sharpness of detail is the size of the area that your light comes from, okay? This in the X-ray tube is equivalent to saying this would be the small focal spot setting, and this would be like the large focal spot setting, okay? Over here on the right, all of the light is now being emitted by some larger thing like the sun, okay? The sun is not a point source in the sky. When you look up at the sun, you notice the sun takes up some area on the sky, right? Not a point source, okay? There's light coming from that side of the sun and from that side of the sun, okay? Light that comes from this side of the sun, some of that light is going to strike this edge of the body part. Some of that light is going to come down and strike this edge of the body part, okay? And light coming from the opposite side, some of it's going to come down and strike that edge, but then some of it's going to come down and strike the opposite side, okay? Because of that, because of this wide area where the light is originating from, what you get is you get light rays hitting and representing what is the edge of the body part, but over a larger area, okay? Said in the way, the terms that we like to use, the penumbral shadow becomes larger with a larger source of light. Where the light is a large source versus a small source, the large source of light produces unsharpness at the borders, called penumbral shadow. We're going to keep talking about this, so I'm not going to go away from this image. Is used a couple more times. So, umbra, okay? Umbra is the shadow of the body part. Okay, it represents the size of the body part. It's the pure or true portion of the shadow, which has uniform darkness. You notice when you stand out in the sun, your shadow is sort of all one shade, right? It's all one shade of shadow color, right? Dark. But penumbra is blur at the edge. We'll talk about penumbra in a second. Penumbra, different than umbra. Umbra is the shadow of the body part. Penumbra is going to be the edge, the blurred edge. So here's penumbra, a scientific term for blurriness of the image edges. The width of the penumbra, the width of the blurry area, can be predicted and measured. I'm not going to focus. The book will probably have you do some things with this. My focus is going to be more on understanding the relative relationship here, right? Large areas produce penumbral blur. Small areas produce less penumbral blur. Said in X-ray terms, small focal spots give us better, or small focal spots give us increased sharpness of detail, and larger focal spots give us less sharpness of detail. Okay, but this is the why behind the whole thing. You can do this very easily with a flashlight, right? You can take it assuming the source from the light to the object is fixed and the object to the image distance is fixed, right? Assume those things are fixed, you can take a large source of light, like the light in this room, and notice that your shadow is blurry, right? You can look down at the ground and see that there's not a clear image of the table or your hand or whatever you want to cast a shadow of, right? And then again, as I've said before, you can take a small flashlight and do the same thing, and notice that the small flashlight produces a much clearer shadow of your hand, right? So that's because the source of light was a small source with a small flashlight and a large source with using all the lights in this room, for example. Now here's the problem. We have more than one object we're looking at in X-rays, right? So if two objects are close together and there's a significant enough amount of penumbral blur, it can be difficult to distinguish where one object ends and the other begins if they're sufficiently close together. You blur the edge of the body part big enough and it will overlap the blurred edge of another body part.
So you're saying that the bone and the muscle next to it, you can't figure out where they end.
It can be more difficult to figure out where one ends and the other begins with more penumbra. So you want less, right?
Less.
And the ways we get less penumbra, if source to image distance is fixed and object to image distance is fixed, the only way to change that now is to go to the small focal spot versus the large focal spot. But remember, as I'm about to get into, your source to image distance is not necessarily fixed, and your object to image distance is not necessarily fixed. So those things will affect it too, okay? But I was just giving the example of fix those two things, and then focal spot size is going to be the controlling factor.
So like if somebody has a bone tumor, we want to see the sharp edges to
Sure.
see how large the tumor actually is.
Yeah, we want to see where it ends, right?
Okay.
And less blurring to the edges can help with that, right? Now there's a give and take here, right? Because with the small focal spot setting, you're not able to access high mass numbers. Remember, mass is given by the MA and the time, right? Well, your milliamperage setting controls which focal spots you have access to. Okay, let me go over to here for example. On this X-ray tube control console, you're only able to access the small focal spot setting at 50 and 100 milliamps. Okay, so that means if I wanted to use small focal spot, I'm locked into those two settings, and which means I would have to use a relatively longer time setting. Okay, if I used 100 MA, and well, for a tenth of a second, that'd be 10 mass, right? 100 times 0.1, right? 10 mass. If I wanted to make 10 mass but have a shorter time, I really couldn't, right? If I'm left with 100 MA as my only option, okay? The only way to get a shorter time setting would be to go up to 200 MA, is in my example, right? But at 200 MA, I'm locked into the large focal spot now, okay? So we make settings, those settings determine which, for example, focal spot we're accessing, and that's going to make geometric changes to the image. So you have to weigh, is it worth getting the extra detail to risk the patient moving, right? That's the risk of having longer time, is the patient moving.
Okay, so yes or no, well, I don't want to go too far off of your path.
Thank you.
But, you know, I'm going to be pretty.
I want a yes or no answer.
Because I'm going to ask
with
an
you.
obscure question. So does like columnating, you know, to a smaller spot then affect the sharpness or not? Or do that?
So my one-word answer.
Or is that irrelevant? Oh,
No.
it's irrelevant. That's what I just wanted to verify. I know why I was asking that. But
That's good. You guys gotta
I know what I do.
lock me down to a couple of words, right? Don't let me talk for too long. That's funny. All right. That's really good. So, okay, so focal spot size affects penumbral blur, the blurred edge of the shadow, and when you can access the small focal spots, you will achieve a greater image detail than when you access the large focal spot settings. And to be clear, you access small focal spot settings when you're using the low milliamperage numbers on the control console, okay? Different control consoles are different. That one happens to only let you get to small focal spot at 50 and 100 MA. Others, different generators, might be different, okay? So why would you even have a large focal spot? The large focal spot settings give us less detail, but they allow us to get to much more, much higher quantities of X-rays without overheating the X-ray tube. Okay, small focal spot packs all of the electron bombardment into a small area, right? Large focal spot spreads that area out to disperse heat a little better. So it's better for the equipment to get on the large focal spot. It's just not better for the image. Your job's going to be to choose when it's appropriate. I bet you when you ask X-ray techs out there, hey, are you on the small or large focal spot? They're either going to say what, or they're going to say, no, I don't care, right? Because in actual practice, it's going to be kind of hard to tell the difference between an image shot on small focal spot and an image shot on the large one. Because the amount of penumbral blur is small. The amount of change in the blurred edge is very small. Okay, it's there in principle and in practice. It's just hard for the human eye to tell that difference. We try to do it when we can. Okay, so for example, body parts that are small and have small detail to them, and also don't use that much mass. You don't need that much MAS to make the exposure. Those would benefit from that small focal spot with the added detail. Let's get some more stuff going. Motion penumbra. Motion penumbra is movement of the light source or the recording surface. So either the cassette under the patient shifts around, or the X-ray tube like physically shakes around because it's like unstable in its stand or something like that. Or as we learned earlier, remember the anode's rotor is supported by bearings, and those bearings can wear out or warp, and making the anode kind of shake as it spins. Geometric penumbra and motion penumbra destroy sharpness of detail. Okay, so to be clear, penumbra and umbra are geometric properties of the image that have to do with the size of the source of the light, as well as how far the light is from you, and how far you are from the surface that the shadow is cast on, or the image receptor in radiography. If the sun were much closer, on top of other bad things that would happen, our shadows would be blurrier. Okay, if our sun came twice as close to us, a number of other weird things happen, but to start with, your shadows would be blurred. The edges of your shadows would be much blurrier. Okay, or if the sun were the same distance away but twice as large in the sky, right, or 4 times as large in the sky. Okay, it would make your shadows blurrier. If the sun were much further away, on top of other weird things that would happen, your shadows would be clearer at the edges. The edges of your shadows would become clearer. It has to do with the size of the source of the light. Again, anytime you're wondering about penumbra, just think back to my example of all the lights in this room casting really messed up blurry shadows versus a single flashlight casting a nice clear shadow. Okay? The clearness of the shadow comes from the penumbral edge, the edge of the shadow. Smaller light source equals clearer edges. All right, 2 more notes. These last 2 notes are going to be on what we call distortion. Okay, distortion is, so my definition of distortion is a misrepresentation of the size or shape of an object. One more time, misrepresentation of the size or shape of an object. Misrepresentation of size or shape, those are 2 different things. Size is one thing, shape is a different thing. Let's first talk about size. That's easy. So misrepresentation of size is called magnification. So we can't minify the object. Let me make a small caveat. You can make an object appear smaller than it actually is. However, the only way to do that is the source of light has to be bigger than the object. Okay? So if an object is smaller than the source of light, the object will always be magnified. Okay? If the source of light always has to be smaller than the object, which is true in everything we do in radiography. If the object, we wanted to make it smaller than it is in real life, the source of light would have to be larger. I can show that somewhere. Here you go. So let's just look at this picture real quick. So, source of origin of light, right? Light starts from the focal spot, okay? These lines are representing the light being emitted, okay? And we're just talking about the light at the edges because we don't care about what's happening in the middle necessarily. You see an object here and an object here, okay? Both objects we're going to say are the same size, all right? If the source of light is small and the object is large relative to the source of light, those light rays are going to hit the object and then continue to spread out towards the image receptor, towards where the shadow is being cast, casting a large, only pay attention right now to the umbra. The umbra is large here, okay? When you get a source of light that is as large as the body part, the shadow cast is the same size as the body part, okay? Extend that further, if the source was larger than the body part, the lines coming down would converge on a smaller area and make the object look smaller than it actually is in the real world, okay? When the source of light is small relative to the object is always magnified, okay? If the source of light were the same size as the object is not magnified. In radiography, our source of light is about a millimeter squared, okay? So any object larger than a square millimeter, by the way, the millimeter squared is the large focal spot. The small focal spot's about a half millimeter, okay? So any object, let's use the small, any object larger than a half millimeter square will always be magnified, meaning everything you're going to see in the body is going to be slightly magnified, like this, okay? Notice on this one, small source of light relative to the object produces an umbral shadow. The size of the body part, the umbra, is large relative to the object. But look at the penumbra, it's small, okay? The object gets clearer, but is magnified. Okay, the object is larger than it is in real life, but it's clear at the edges. When the source of light is large, the actual shadow is smaller, less magnified, but the edges blur more. So there's a give and take. You get better sharpness of detail with a small source of light, but you lose size detail. The object will look magnified, okay? With a large source of light, the object can be represented as its true size, but you lose the edges. The edges are now going to be blurry, okay? Which is sort of what you're seeing in this room, right? Your shadow of your chair or table or whatever is going to be more closely related, it's going to be closer to the size of the actual table or the size of the actual chair, but what have you sacrificed? You've sacrificed edge detail, sharpness of detail, right? The objects that we're casting shadows of from the light in this room, they're as big or smaller than they are in real life because the source of light is large relative to the objects in this room, right? Relative to my hand or whatever, the source of light is very large. So the shadow cast will be most likely smaller than my actual hand is in real life. So I've minimized the size of my hand. I definitely haven't magnified it, but I've sacrificed edge detail, okay? This is the lesson. When you use small focal spot settings, you necessarily magnify the body part, but you gain edge detail. Your penumbral shadow is smaller. When you use the large focal spot settings, you show the body part truer to its actual size, closer to its actual size, but you lose edge detail. Most of the time, we're okay sacrificing size, we're okay with the object being magnified, that's fine, as long as we get the detail, the sharpness of detail at the edges, okay? So when possible, when at all possible, this is the ultimate part of the lesson, when at all possible, we utilize the small focal spot setting because the source of light is smaller. When we can't use the small focal spot, we understand that we have to move to the large focal spot, understanding that we sacrifice edge detail, but we gain the body part looking closer to its true size. Now, in all reality, the difference between the small and large focal spot is not that much, right? It's 4 times larger for a half millimeter squared to a millimeter squared. Not that much difference, but it's there. This has been exaggerated for our purposes. for learning purposes.
What is constant? What is constant?
It is. This is true regardless of the size of the spot, focal spot, the size of the object, or the distances. Right now, that's everything I'm going to give you for today. We're going to need to continue on this next time because I do want to go ahead and let you guys out of here and start my lab group. Hang on to the quiz you were given. I want you guys to work on that, finish it, study it, because I'm going to give you questions from that on the final exam, okay? The next time we meet, I'm going to give you a similarly sized quiz for this information, okay, that we talked about today. So go back, study, bless you, study this stuff, and then before you go, as long as you want it, I have the lecture notes, 13 and 14 up here, okay? So come snag a copy of the lecture notes that we did today, and we'll continue with this next time. Small pop quiz at the beginning of class next time. If anyone has questions, please stick around. I want to get my lab group running real quick, but I can answer questions after that. If you are my second lab group, you have about an hour, okay? So go get some lunch or something. Hang tight, do homework if you want, but second lab group won't go in until 1 o'clock, okay? So I don't know, you have to check who you are on there. Yep. All right, first lab group, you ready? Now, first lab group, you guys are done with lab 1. Did you bring it back to turn in?
I still have to write some stuff.
Okay,
I mean, I
so,
have it,
we'll want to finish this up as efficiently and soon as we can, but you have the second lab packet, which we're going to get started on, and everyone in this first group with me today, Abby, Maria, Lily, Alicia, have you all done lab experiment group 1? Have you all done the first lab? Oh, so,
Yeah, we didn't sign up by groups, so now if I go
okay.
into the group with
Well, that's gonna
them,
be a problem.
I can't do, I already did lab 1.
okay, so you're going to need to stick with the people that you were doing the lab with, okay, that you started the labs with, okay? So, that's not going to work, okay.
Yeah, I think we all just kind of signed up on random days.
Yeah, random stuff.
Okay, everyone who doesn't need to be here, have a good day. And everyone else, I'll talk to you. Questions? Yep, staying for lab.
I just want to know my final result. You can get to me later on.
How do you know about what?
The final result?
That?
Yeah, did you not?
Yeah, we finished the first one. I didn't finish writing it down, but if we
I
had
gave out
finished it,
evaluations.
Oh, that was it?
Yeah.
the other option is
Grades,
we'll
the
give
evaluations?
Yeah.
Yeah.
everyone
Put it onto one together.
Oh, okay. So
You want to know about the exam? You got to go talk to Jackie. Anyone who gets above the passing score, I don't need to show you the exam. But if you want to see, you just go talk to Jackie and you can grab it. Yeah, you're fine. So
yeah, I have to write the explanation.
this isn't gonna work. Lily and Alicia, can you guys come at 1 o'clock instead of 2, or instead of 12 right now? Can you wait and go and do the lab with Joe and Enrique? Because they're on their first experiment, and this group is going to be on their second lab. Sorry. So, Abby, you're on your second lab.
Yeah. That's
Maria,
good.
you're not. You're on your first.
Really?
Lily, you're on your first, and Alicia, you all three are on your. So you're the only one.
It's all us. We were the only people in there last week.
Right, but you're the only one signed up for right now.
Yeah.
Okay.
Because I was like gonna get everything out.
Okay.
But they didn't sign up.
That's
but
fine.
now-
So that's fine. We can just go in now.
Okay.
And you go in and start, and then I'm gonna bring these guys in, and we're gonna go in
I was
between.
gonna say, if they wanna do lab 2 with me, they could. Cause it's not
Yeah,
sequential.
that's fine. That's not sequential at all.
Yeah.
That's a better idea. Thank
It's
you,
not
Abby.
sequential.
That's what we're gonna do.
Which means you guys
So
have
get
to
laboratory
wait
2
till
out,
you're
general lab 2. I gave you guys both of them. Just get general lab 2. We'll all go in together and we'll all do 2. That's perfect. Thank you, Abby.
Leave yours here, or is mine?
Me too, right? Joe, you're with me from 1 to 2.
I'm not sure though.
Not having you.
You and Enrique I've got from 1 o'clock to 2 o'clock, okay? So yeah, come back at 1, right at 1, okay?
If I did a lab with 1, that means when I come back 1 o'clock, is that
Well,
lab
that
2?
means that
Yeah, you're
they
gonna be
can do
working
lab
on
2 as well.
2, I guess, yeah. So you and Joe will be working on different stuff, that's fine. I can't have more than 4 people in the room at a time though, so I can't keep you with me right now. Okay?
So we have to wait till lab 2.
I mean, if you wait towards the afternoon, they can do with Joe Lab 2 as
So
well.
Abby, Maria, Lily, Alicia, you guys all come with me right now. We're gonna go into the X-ray room. Make sure you have your badges. If you don't have a
I
badge,
need to borrow a badge.
I gave mine, but I never got one back.
yeah, if you don't have it, or turn it in, we'll get you yours. I'm sure it's here. If you have your badge, go ahead and put it on. If not,
I need to borrow one.
I know,
Yeah.
right? Could we just like go, we'll change everything else in my car, go get it back in the car. I know, we got
something to write with in the lab packet.
Do you have extra paper?
Like scratch paper?
Yeah, for like the summer.
Yeah, I had back in the X-ray room.
Can we leave our stuff here?
Yeah, it's all safe. It's safe. Just, I mean, you know.
Yeah.
Can I pull my
Good.
backpack in the car?
Please feel free. Yeah, yeah.
Or should I leave it
You
here?
just need something to write with.
Okay.
Yeah. So we're gonna go back to the X-ray room,
Great.
and looks kind of okay. You've done the lab. They haven't.
I like your red scrubs.
Thank you. Are you staying for lunch?
No,
No, you're not, huh?
no.
I think
Ours
I
is
left
getting
my
into the
stuff from the car because you know how you leave it in the sun and it
Oh, yeah,
melts?
yeah.
I hate that. I'm like, let me go get my stuff because I need to stay here.
Alright, I'll see you tomorrow.
Alright, bye. I feel like it makes sense to recommend like help I hear you, yeah. So for this one, I like to do qualitative grid until what you would imagine, like they say perpendicular, but think where you would imagine like a line to be. So just kind of like angle, like you're gonna get like simple line-ish. You're going to walk, you're going to sort of up underneath the ribs. Have your patient take a deep breath in.
So which one are we on? We're on the right kidney?
No, gallbladder makes no blood pressure.
Oh, okay.
Support.
Okay.
So I have a question. So how far does our so like you know how we can see the pregnancy where you know we used to have one that we were able to do on a mannequin, but the simulator doesn't work. So really the only option we have is to do transvaginal if you have which if you have a friend that you want to bring in, oh yeah, you can have like classmate that's willing to do it with you. Like as embarrassing and weird as it may seem, the fact of the matter is like we're all going in the same profession. And you're gonna see vaginas. You're going to have to do your time to vaginas. Like it's just becomes very important. It's not that I feel like because like there's for you, I don't know what's behind it.
Yeah.
I mean everybody's gonna start something. And I mean if you've got a partner that's willing to allow you to do it to them, it's a nice thing to do would be to allow them to do it to you also.
So it goes all the way in. Oh.
You only put about that much of it in. Well, that's what I was just saying, like, if you have a classmate that's willing to do it with you, or if you've got somebody, like, outside relative, friend, significant other, like, but, like, whatever the situation, like, you're more than welcome. We got what we need, and we did it perfectly. Like, we have the equipment to do it, it's just really, we can't force anybody to do it, but if anybody is willing to do it,
So you needed to know reaching our head, right?
you don't have to do transvaginal for OB. It's in the beginning portion of the vaginal to use transvaginal. That's what I've been trained to adopt. cardiac. So what you want to do is you want to go completely coronal. Okay. Like it's like pointed right there just because of the way it's raised. Right low. Right low. Right. Yep, so it's the first five. I'm gonna go over those one more time. Okay, really quick. So left low aorta. Left low diaphragm. Body low. Body lobe, right lobe IC, right lobe IC, gallbladder, fourth wing. Or right. So, like when we're out on the field, if the doctor asks for an injection of liver, we use something. It's exactly. Any questions?
I'll have some later.
Okay, perfect. I like what you said. Oh yeah, absolutely. We'll get into measurements for everything, especially once we get into phase two. That's when we get into the nitty-gritty of everything. We'll be doing common bile ducts, we'll be doing hepatic arteries, hepatic veins, it will get into all. Alright.
I think I got it written down. Yeah, I had to do a bunch of stuff. I don't know if I was doing it.
So the I is going to be more towards the right, and then also, if you're at the proximal aorta, it branches off. It has two branches that come off of it. So, you know that has two branches coming off of it? That's another way I know that. Or sure aorta. So that's going to be your celiac trunk and your splenic artery. And then you see this little chunk right here, right under here. That's the head of the pancreas. But anyways, yeah. And then you see how that's like going. You got that. Oh, okay. So that's the aorta. So I can do the right under it. It's not right necessarily under it. They work like perfectly to the future. So like that's it. IBC aorta. They're right next to each other. And another thing, like IBC is flat, but I feel like aorta has more of an angle to it. And the way it pulses. Like if you watch the IBC, it has more of like a flutter. And it was kind of like flutters a little bit. Yeah. Aorta. It pulses. are doing your scan, label your key terms. When you guys are done with what machine you guys are using, so I can go back through and make sure you guys are getting the whole concept of key terms.
You want us to label the key terms?
Label key terms, and then on your sheet, write your name, what system you're on. So go ahead and get your transfers. So go long. Go long. Another way. Basically, your patient's head or you.
Oh, I thought I was like down
First, very little. You take a deep breath. Just for left foot. See this big huge thing going on here? That's your fingers. Shallow stuff. Looking. So look. The left leg lean. Still take a look out. Let me see if I can adjust your settings a little bit better.
Okay, so do you want us to write on this page or
What's that?
do you want us to write on this page?
Or the page that has the key terms on it, either or. I just want to know what system you guys are working on so that